What if one of the most powerful longevity mechanisms in the human body could be influenced without skipping meals? What if you didn't need to endure long fasts? What if the secret wasn't hidden inside an expensive supplement or a revolutionary drug, but inside one of the simplest foods on earth? Beans. Now that might sound impossible, because when most people hear the word autophagy, they immediately think about fasting, going without food, restricting calories, allowing the body to enter a state of cellular cleanup. And for good reason. Fasting has become famous because researchers discovered it can activate powerful biological pathways associated with cellular maintenance and repair. But recently, scientists have begun paying attention to something surprising. A different route. A pathway that may influence some of the same longevity systems without requiring complete food deprivation. And at the center of this discovery is a little-known amino acid called methionine. Most people have never heard of it, yet it may be one of the most important molecules involved in aging, metabolism, and cellular repair. Today, we're going to uncover the fascinating relationship between beans, methionine, autophagy, and why some researchers believe this nutritional secret may help explain the remarkable health benefits observed in some of the world's longest-living populations. But first, let's start with a question. Imagine a city with millions of buildings. Every day, damage accumulates. Broken windows, faulty wiring, cracked foundations, rusting machinery. If nobody performs maintenance, the city gradually falls apart. The same thing happens inside your body. Every second, billions of cellular reactions occur. Proteins become damaged. Cellular components wear out. Waste accumulates. Errors appear. To survive, your cells need a cleanup system. A way to identify damaged parts and remove them before they become problematic. That cleanup system is called autophagy. The word literally means self-eating. But don't let the name fool you. Autophagy is not self-destruction. It is self-renewal. Think of it as the body's recycling department. Old materials are broken down. Useful components are recovered. Damaged structures are removed. The cell becomes cleaner and more efficient. Scientists consider autophagy one of the most important biological processes associated with healthy aging, because aging itself can be viewed, at least partially, as the gradual accumulation of cellular damage. The better the body manages that damage, the better its chances of maintaining function over time. For decades, researchers searched for ways to influence autophagy. Again and again, one intervention kept appearing: fasting. When nutrients become scarce, cells receive an important message. Resources are limited. Waste must be minimized. Efficiency becomes critical. The body responds by increasing maintenance and recycling activities. This is one reason fasting attracted so much scientific attention. But fasting is not always easy. Many people struggle with it. Others cannot safely practice prolonged fasting because of medical conditions. And that's where the methionine story begins. Imagine your body as a giant manufacturing company. Every factory requires raw materials. Without them, production slows. One important raw material is protein. Proteins are built from amino acids. And methionine is one of those amino acids. At first glance, methionine sounds completely ordinary. Just another nutrient. Just another building block. But scientists eventually discovered something remarkable. Methionine acts like a biological signal. A signal that tells the body information about nutrient availability. Imagine a factory manager monitoring incoming shipments. If shipments are abundant, the manager encourages growth and expansion. If shipments decrease, the manager shifts priorities. Maintenance becomes more important. Efficiency becomes more important. Resource conservation becomes more important. Researchers believe methionine functions in a surprisingly similar way. When methionine levels are high, certain growth-related pathways remain active. When methionine availability falls, different biological responses begin emerging. And some of those responses appear connected to longevity. This discovery shocked scientists. Because methionine is not distributed equally among foods. Some foods contain enormous amounts. Others contain relatively little. And one category of food consistently attracted attention: beans, lentils, legumes, Plant foods that naturally contain protein but often provide lower methionine levels compared to many animal-based protein sources. Now here's where things become fascinating. Researchers studying longevity repeatedly noticed something unusual. Many populations known for exceptional health and long life consumed large amounts of legumes. Not necessarily because they understood methionine, not because they were trying to activate autophagy, but because these foods formed part of traditional dietary patterns. At first, scientists assumed the benefits came primarily from fiber. And fiber certainly matters. But the story appeared more complicated. Because legumes influence multiple biological pathways simultaneously, including pathways connected to nutrient sensing. Think of nutrient-sensing pathways as biological control centers. They continuously monitor the body's environment. How much food is available? How much energy exists? Are resources abundant or scarce? Should the body prioritize growth or maintenance? One of the most famous pathways involved in this process is called mTOR. You don't need to remember the name. Just remember its role. Because mTOR acts like a construction manager. When nutrients are plentiful, construction accelerates. Growth increases. Protein synthesis expands. The body builds. This is essential. Without growth signals, life would be impossible. But researchers discovered something interesting. Constant activation may not always be ideal. Imagine a city that only builds. New roads. New buildings. New infrastructure. But never repairs existing structures. Eventually problems accumulate. Maintenance becomes neglected. The city grows larger but not necessarily healthier. This is why balance matters. The body needs periods of growth, and periods of repair, periods of construction, and periods of cleanup. Scientists observe that methionine availability appears capable of influencing some of these pathways. When methionine becomes lower, cells may shift attention toward maintenance-related activities, including processes associated with autophagy. Now let's be very careful here. Beans do not magically activate autophagy to the same extent as prolonged fasting. The science is more nuanced than that. What researchers are investigating is whether lower methionine dietary patterns may help create conditions that support some of the same maintenance pathways involved in healthy aging. In other words, not identical effects, but potentially overlapping biological signals. And that possibility has generated enormous excitement. Because it suggests that what we eat may influence aging not only through calories, not only through vitamins, not only through minerals, but through information. Nutritional information. Signals that tell cells how to behave. Signals that shape biological priorities. Signals that influence maintenance and repair. But the most surprising discovery came when scientists started examining what happens inside the mitochondria, the tiny energy generators inside your cells. Because that's where the real longevity story begins. Now imagine a city powered by millions of tiny energy plants. Every building depends on them. Every service depends on them. Every repair crew depends on them. If the power plants function efficiently, the city thrives. If they become damaged, everything begins slowing down. Inside your body, those power plants are called mitochondria, tiny structures responsible for producing most of the energy your cells need to survive. For decades, scientists viewed mitochondria simply as energy generators. Today, they understand something much bigger. Mitochondria are also information centers. They help determine how cells respond to stress, how efficiently energy is produced, how damage is repaired, and ultimately, how aging unfolds. This is where the methionine story becomes even more fascinating. Because researchers discovered that lower methionine availability appears capable of influencing mitochondrial behavior in surprising ways. Imagine a company suddenly facing tighter budgets. Managers begin examining every process more carefully. Waste is reduced. Efficiency improves. Resources are allocated more strategically. Something similar appears to happen inside cells when certain nutrient signals change. Cells become more selective, more efficient, more focused on maintenance. And maintenance is one of the central themes of longevity science. Because aging rarely happens overnight. Instead, it happens one damaged protein at a time. One malfunctioning mitochondrion at a time. One missed repair opportunity at a time. The body can tolerate small amounts of damage. In fact, damage is unavoidable. The real question is whether the body can keep up with repairs. And this is why researchers have become so interested in dietary patterns that support cellular housekeeping. Not because they promise immortality, not because they reverse aging overnight, but because they may help slow the accumulation of biological wear and tear. Now let's talk about another major player in this story. Oxidative stress. Imagine sparks flying from a machine. A few sparks are normal. Too many sparks become dangerous. The same principle applies inside cells. Normal metabolism generates reactive molecules. Small amounts are harmless. Some are even useful. But excessive accumulation may damage proteins, DNA, and cellular structures. This process is often called oxidative stress. Think of it as biological rust. The more efficiently the body manages it, the better its chances of maintaining long-term function. Interestingly, legumes appear to provide benefits that extend beyond methionine levels. They contain fiber, polyphenol, minerals, plant compounds that interact with numerous biological systems. Researchers increasingly suspect that many of these components work together rather than independently. Imagine an orchestra. No single instrument creates the entire performance. The magic emerges through cooperation. Similarly, the health benefits associated with legumes likely result from multiple mechanisms operating simultaneously. Fiber influences gut health. Plant compounds influence inflammation. Protein supports maintenance and repair. Lower methionine availability influences nutrient-sensing pathways. Everything works together. And that cooperation may explain why legumes appear so frequently in dietary patterns associated with exceptional longevity. Now let's visit some of the world's longest-living populations. Researchers studying longevity hotspots repeatedly noticed a recurring pattern. Beans. Lots of beans. Whether in Mediterranean communities, certain Asian populations, or other regions known for remarkable life expectancy, legumes consistently appeared as dietary staples. At first glance, this seems almost disappointing. People expect longevity secrets to be exotic, rare, complicated. Instead, researchers kept finding ordinary foods. Foods available in grocery stores. Foods consumed for thousands of years. But perhaps that is exactly the point. Nature often hides extraordinary biology inside ordinary things. And beans may be one of the best examples. Because while modern nutrition frequently focuses on individual nutrients, traditional diets often succeed through overall patterns. People weren't eating beans because they understood mTOR, or autophagy, or methionine restriction. They ate them because they were affordable, nutritious, accessible, and sustainable. The biological benefits came along for the ride. Now let's discuss another fascinating concept: metabolic flexibility. Imagine owning a hybrid vehicle capable of switching effortlessly between fuel sources. When one fuel becomes scarce, another takes over. Performance remains stable. Efficiency remains high. The human body evolved similarly. Throughout most of history, food availability fluctuated. Periods of abundance alternated with periods of scarcity. The body developed systems capable of adapting. Unfortunately, modern lifestyles often reduce that flexibility. Constant food availability means some metabolic pathways remain continuously active. The body spends less time engaging maintenance programs that evolved during resource fluctuations. Researchers believe this may be one reason fasting attracts so much attention. It temporarily recreates conditions humans frequently experienced throughout evolutionary history. But lower methionine dietary patterns may provide another way of influencing some of those same signaling systems. Not identical, not equivalent, but potentially complementary. And that possibility has enormous implications, especially for people who struggle with fasting, because it suggests there may be multiple paths toward supporting healthy aging. Multiple ways to influence nutrient-sensing pathways. Multiple strategies for encouraging cellular maintenance. Now let's address one of the biggest misconceptions. Some people hear about methionine restriction and immediately assume they should eliminate protein. That would be a mistake. Protein remains essential. Muscle maintenance depends on it. Immune function depends on it. Hormone production depends on it. The goal is not deficiency. The goal is balance. Think of a thermostat. Too high creates problems. Too low creates problems. The sweet spot exists somewhere in the middle. Most longevity researchers are not advocating nutritional extremes. Instead, they focus on creating dietary patterns that support both growth and maintenance, both strength and repair, both performance and resilience. And beans fit remarkably well within that framework, because they provide substantial nutrition while simultaneously influencing pathways connected to longevity. Now imagine two individuals reaching age 70. The first accumulated decades of metabolic dysfunction, chronic inflammation, poor dietary quality, limited cellular maintenance. The second consistently supported biological repair systems through healthy habits. Neither person escapes aging, but their trajectories may look very different. This is one of the most important lessons emerging from modern longevity science. The goal is not avoiding age. The goal is improving the quality of aging, maintaining function, maintaining independence, maintaining vitality, for as long as possible. And that brings us back to the simple bean, a food often overlooked, often underestimated, yet potentially capable of influencing some of the most important pathways in human biology. Not because it contains magic, not because it performs miracles, but because it communicates with your cells. It provides information, signals, instructions, messages that help determine whether the body prioritizes growth, maintenance, repair, or efficiency. And the methionine secret reveals something profound. Food is not just fuel. Food is information. Every meal sends biological messages. Every bite influences cellular decisions. Every dietary pattern shapes long-term outcomes. The choices made today become the biology experienced tomorrow. So the next time you see a bowl of beans, remember this. You are looking at more than a source of protein, more than a source of fiber, more than a simple food. You are looking at a nutritional package that may help support some of the same maintenance pathways scientists have spent decades studying. A food that has quietly accompanied some of humanity's healthiest populations for generations. And a reminder that sometimes the most powerful discoveries in science are not about finding something new. They are about finally understanding what has been in front of us all along.